Hi everybody, this is section 4.2 in our Hawks textbook on college algebra, and it is on linear and quadratic functions. Okay, so first we're going to look at linear functions, and again, this is really not anything new. We've looked at linear equations. Remember, there are equations that are always in the first degree, so that means the x or the variable in the equation is to the first power, and here we're calling them linear functions. What makes it a function instead of an equation? So far we've really dealt with like y equals mx plus b if it's in slope-intercept form. Function form would be f of x, or f of a variable, equals your ax plus b, or whatever your variable is. Like these would be the same if it's in slope-intercept form. But that's really the only thing different is they put the f of x instead of y. It really is just like your y coordinate, and it just means when they have this notation that it's already, we know it's a function, it passes the vertical line test. All right, so here we're just going to graph two linear functions. So our first one that we have is f of x equals 4 plus 6x all divided by 2. What we're going to do with this equation before we graph it is, instead of putting our f of x there to help us graph it, we're going to make it y equals, and I am also going to make it so we can simplify it a little bit, because I know those fractions can be scary, but I do recognize that 2 goes into both of those. So if I split up that denominator and make it 4 over 2 plus 6x over 2, it is going to end up being y equals 2 plus 3x. And now, honestly, it's in slope-intercept form. Only thing you might want to do is rewrite it so you put the 3x first, and then the y-intercept. Remember, this is your slope. This is your y-intercept. So when we go to graph it, we could plug in values for x and find a y value to get some ordered pairs. Or, I know that this, remember, this 2 is my y-intercept. So that ordered pair is 0, 2. So I can go plot that on my graph. And my slope, or m, is equal to 3, which is the same as like 3 over 1. So remember, slope is rise over run. So I will go up 3. So 1, 2, 3 over 1. There's my other next point. I can put a third point in for insurance purposes. Go up 3. 1, 2, 3 over 1. There's my last point. And then we can draw our line. And again, I don't know why it won't go, when it goes crooked, why it won't go straight. But there is our equation graphed for A. Now let's take a look at B. For B, it is g of x equals 3. There's no variable there. But remember, g of x, we said, is just like having y equals. So now we have this. We have the equation y equals 3. Remember, with the y equals equation, what kind of line are you going to get? You should, if you recall, like if I were to make a t-chart, we know that y is always 3. And x can be anything. I'll make it like 0, 1, and 2. But we should, when we graph it, like here's 3, 0, or 0, 3, 1, 3, 2, 3, it will give you your horizontal line. So when you have g of x, or f of x, or h of x, or anything of x equals 3, or any number, it's really a y equals equation. So you're going to end up with a horizontal line when you graph that one. All right, so that was it for linear equations or functions. Now we're going to look at quadratic functions and their graphs. And again, we've graphed quadratic functions before. We know that their graph is a parabola shape. So like if I sketch a graph here, my coordinate plane, here is a parabola. All right. And again, it's a second degree function, so the variable is always to the second power. In standard form, it's written ax squared plus bx plus c. We are going to look at vertex form in a minute. Now, when you have a parabola that you have graphed, there is always going to be the vertex of your parabola, which we are going to talk about quite a bit. So here's my vertex. The vertex is always in the form of HK. And again, we'll talk about that more in a second when we look at the vertex form of the equation. But the vertex is always the absolute maximum or the absolute minimum of your parabola. In this case, because my parabola opens up, so the line's face, it goes upward. It's like an upward, call it U. The vertex is the minimum of the equation. And when they ask you for like the absolute minimum of the equation, they are actually, when they ask you for the minimum value of the equation, they are looking for the y or the k value of the equation. So when they say the minimum, they want the k value or that y value there. They may also ask you for what we call the axis of symmetry. And the axis of symmetry goes straight through the vertex, and it basically divides that parabola into two equal parts, because they should rise up the same on both sides. Now, your axis of symmetry, and it is you'll notice it's a vertical line, which our vertical lines are your x equals equations. So if they ask you for the axis of symmetry, they're actually looking for the h value. So if they ask you for the axis of symmetry, it's going to be the h value in your vertex. And these are all things that we're going to look at as we move through our quadratic functions. Okay, so I did just mention a minute ago that we are going to look at the vertex form of the quadratic function. And the vertex form is g of x or f of x, h of x, whatever it is equal to a times x minus h squared plus k. And again, remember your vertex is hk. So if it's in a vertex form, you can identify the vertex quickly and easily. And a can never be equal to 0 because 0 times anything is 0, so it wouldn't make it a parabola. And then another thing that they talk about is the width of your parabola. So if you have a parabola where a, the absolute value of a, so it doesn't matter if it's positive or negative, but if you look at the absolute value of that number, if it's a number greater than 1, so like 2, 3, 4, 5, that means that your parabola is going to be narrower than just g of x equals x squared, where it's our typical parabola. So it's going to be narrower or skinnier. And if a is between 0 and 1, so basically think of it this way, it's a fraction, a proper fraction. So it's like 1/3, 1/2 a, something like that. And again, absolute value, doesn't matter about the sign. Then the parabola is going to be wider than f of x equals x squared. So the equation would look wider, or I call it fatter. Now, the other thing that you can determine from a, you can tell a lot from the a value, is if a is positive numbers, like positive 2, positive 1/2, your parabola opens upward. If a is negative, it opens downward. So for instance, if I had the equation, let me find one real quick, sorry. All right, let's see. All right, if I have the equation f of x equals 5 times x plus 2 squared minus 29, I can tell a lot of information from this equation in the vertex form. I know that my vertex would be, for my equation, it is going to be -2 and -29. Now, you may be like, well, that's a positive 2 there. Why is it -2? Because if we go back and we look at this equation here, it's a negative h. So that means that whatever h is in your vertex form, you always take the opposite. Okay, so that's my vertex. My a value is right here. It's 5. It's a positive 5. So I know my parabola opens up. I also know that it is going to be narrower than f of x equals x squared. And I also, if I were looking at things and needed to know some information, I do know that my axis of symmetry would be x equals negative 2. And because it opens up, I'm going to have a minimum value. My minimum value, or my minimum value for the parabola, would be y equals negative 21. So there's a lot of information you can get from that equation by just looking at the equation. Okay, so now we are looking at an equation here that is in standard form, and they want us to sketch the graph of the function, write the equation in vertex form, and then state the vertex and find find the x-intercepts. One way to put it into vertex form is you can complete the square, and then you can find the vertex, or, which I find the easier way typically to do this, is to you can find the vertex by, if you have the equation in standard form, you can find the h value by taking the opposite of b and dividing it by 2a. So again, remember this is ax squared plus bx plus c. And then to find the k value, you substitute into your equation. So you do f of negative b over 2a, or you substitute in whatever you found for h. All right, so let's do our vertex equation, or our vertex form here. Let's find the vertex. So b, in our case, is negative 2, but I want the opposite of b. So I'm going to do 2 divided by 2 times, and it's negative x squared, so that's a negative 1, which gives me 2 over negative 2, which equals negative 1. So my vertex, my h value, is negative 1. Now, to find k, what we have to do is we have to take and we have to do f of negative 1. So we have to plug it into our equation. So I'm going to do negative, and then my x will be negative 1 squared minus 2 times negative 1 plus 3. And when you square negative 1, you end up with a positive 1, but we have to do the opposite of that. And then negative 2 times negative 1 gives me a positive 2 plus 3. So it's negative 1 plus 2 plus 3, which if I do negative 1 plus 2, it's 1. 1 plus 3 will give me 4. So my k value is 4. That's my vertex. All right, now I have enough information right now to write my equation in vertex form. Remember, vertex form is your, let me write it up here. We have f of x is equal to a times x minus h squared plus k. So our vertex form would be f of x equals a. In this case, our a is negative x squared, or negative 1. So I'm going to put a negative there. You can put the 1 if you want. You don't have to. It would be x. Now, our h is a negative 1 here, but remember, it's a negative there. So it's really going to end up being plus 1 squared plus our 4. So that would be our equation in vertex form. And then the last thing we have to do before we sketch it, find the x-intercepts. That's really where x equals 0, where your graph crosses over the x-axis when you graph it. So to do that, we can take our negative x squared minus 2x plus 3, set it equal to 0, just like we've done before in the past. Now, we are going to factor this if it's factorable, and it is. But before I do that, I do not want a negative x squared. I want to make positive. So I'm going to multiply everything by negative 1. And what that does is it just makes this, takes away the negative x squared, makes it a positive x squared. You have to distribute it to everything. So now we have a 2x, positive 2x, and a negative 3 equals 0. When we factor that, we're going to have x, let's see, we have to use 3 and 1. I need it's a plus and a minus, so it's going to be both negatives. So, or maybe a plus and a negative, I'm sorry. So it's going to be x plus 3 and x minus 1. And then we'll set those to 0. So now I have x equals negative 3, and then here we'll add 1. So x equals 1. So those are my x-intercepts, which we can use with the vertex to help us graph. Okay, so on the last slide, we figured out this equation. We knew that our vertex was equal to negative 1, 4. And our x-intercepts are negative 3 and 1. Remember, your ordered pair for an x-intercept would be negative 3, 0. And 1, 0. So now when I go to graph it, really you can just put those 3 points in. So here's our vertex at negative 1, 4, and then negative 3, 0, and 1, 0, and then just kind of sketch your parabola. If they want it more detailed, you could find some other points, but for us, that's all we need. Now, if they were to ask me if this equation has a minimum or a maximum value, because it opens downward, it has a maximum value, and the maximum value, remember, is your y value in your vertex. So the maximum value, we would say, is 4, or y equals 4. And my axis of symmetry, if I was looking for that, sorry, it's not very good going down there, but it would be x equals negative 1. That would be the equation for my axis of symmetry, because it goes through negative 1. It is the h value on your vertex. Okay, so here we have a farmer, and he plans to use 100 feet of spare fencing material to form a rectangular garden plot against the side of a long barn. He's using the barn as one side of the plot. So he wants to know how he should split up the fencing among the other 3 sides in order to maximize the area of the garden plot. So we have to find, we're working here with area. And remember, area, the formula for area is length times width. So I find with these problems, a picture is pretty helpful to do. So we are making a rectangular garden. All right, so here is our garden. All right, and then one side of the garden, he is using the barn. So we're going to make this side the barn, so he doesn't need any fencing on that side. Now, he needs to use the other 2 sides. So we need length and we need width. So I'm going to make the 2 sides that are the same, I'm going to call these x, because they're going to be the same length. It's a rectangle. They have to be the same distance. And then the width, or whatever you want to call it, here we have 100 square feet to use. So the width is going to be 100 minus 2x. And I got that 2x from the x's that I've used, that I labeled for the length of the barn. So again, area is length times width. So this is our length. Here's our width. So that means if I were to write an equation right now, I would have x times 100 minus 2x. Okay, so then I can go ahead and I can distribute. So we're going to get area is equal to 100x minus 2x squared. All right, it's a quadratic. So if I go to not factor this, but graph this, it would be, excuse me, a parabola. So what I need to do, I want to maximize the area. Now, my graph is the shape of a parabola. Because this is my x squared term here, it's negative 2x squared. My a is negative. What does that mean about your parabola? I want you to think about it. If the a is negative, the parabola opens down, right? So this is my max value. So really what I need from this problem is I need to find my vertex. So again, we can do the opposite of b over 2a times f of the opposite of b over 2a. If I do the opposite of b over 2a, so here's my b, it is going to be 100, or negative 100, because it's positive 100 there, over 2 times negative 2. So I get negative 100 over negative 4. And when I simplify that, 100, there are 2 negatives, so they're going to be positive. 100 divided by 4 will give me 25. And then what we can do is now we can take this and plug it into our equation. So I'm going to have, we're going to find for k, we'll do f of 25. So it's going to be 100 times 25 minus 2 times 25 squared. All right, which, let's see, 100 times 25 is 2,500 minus, so negative 2 times 25 squared. 25 squared is 625. Negative 2 times that would give me 1,250. And when I do the math there, 2,500 minus 1,250 gives me 1,250. So the vertex of my parabola right here is 1,250. And what I need to answer this question is, how should he split up the fencing among the other 3 sides in order to maximize the area of the garden plot? So basically, he needs to, x needs to be 25. Okay, that needs to be the length of one of the sides. So that's going to equal 25. And then over here, the width, since we already know x, is 100 minus 2 times 25, or 50. So the width is going to be 50. So they need to do the length is equal to 25, and the width needs to be 50. So you need 2 25 sides and 1 50 side. And then this y value or k value, 1,250. What do you think that represents? In our case, it's going to represent the maximum area. So with the 100 feet of fencing, he can have 1,250, I think it's square feet, of garden space. Kind of cool. I know you guys are excited. So anyways, we will talk later. I do have a worksheet for you guys to try for classwork, and I will post that along with answers on Blackboard.